Oh, hey guys. Got my, well, Miss Powell says Ninja Turtle mask on, but as you can plainly see, this is cryptic camouflage, Miss Powell. Everybody that's outdoor people, you recognize this to be cryptic camo, don't you? That's exactly right.
No, looks like Leonardo of Teenage
It's not
Mutant Ninja
Leonardo.
Turtles.
No, no. So I'm going to pull my mask down so we can talk a little bit more about the power rules. Miss Powell did a great job of introducing you to power rules in our last video. And so on this video, what we're going to try to do is we're going to try to talk about some negative exponents. And before we even get to that, dividing powers with like bases. And so we did multiplying with like bases before. And so now we're going to do dividing with like bases. Okay. So Miss Powell, what do you got for us to start with?
Okay, I think we need to go back to the basics and really write out longhand what does 3 raised to an exponent of 5 mean.
And so again, I really like that, Miss Powell, because sometimes I am not thinking really straight. And if I have to, I can always write these out longhand, can I?
Yes.
Now, it's nice to remember the shortcuts because not all the numbers are going to be 2s and 3s. As you're going to see, the numbers get really big. And so when you know the shortcut, it's going to be shorter, hence the name shortcut.
So 3 to the 5th means
Okay.
I have a base of what?
3.
And how many times do I have to write that 3 down?
Again, I'm not thinking 3 times 5. I'm thinking 3 times 3 times 3 times 3 times 3.
Now this time, this has got a division bar. So I got to do a division bar there.
And I love it that you said it like that, Miss Powell, because a lot of times a fraction bar, we don't think about it as a division symbol, but fraction bar means to divide, right?
Yes.
It's always numerator divided by the denominator. Okay, so that's a good teaching point.
And numerator lives on top, denominator lives downstairs, and we're going to be talking about upstairs and downstairs.
Right, and I always remember denominator is D downstairs. That's how I always remembered it too, Miss Powell, when I was taught how to do that.
So 3 to the 3rd, you have a base of 3.
Right.
And I've got to write that base of 3 down 3 times.
And again, I know, Miss Powell, we talked about this in the last video. These rules only work with common bases, right?
Right.
You can only put together things with like bases. Now, they can have different coefficients. They can have different exponents. But the big number, the bases, have to be the same to be able to use the power rules.
Now, if I look at this, what can I do to simplify this fraction?
Well, anytime we had a fraction, we could divide out common factors, couldn't we, Miss Powell?
What's a common factor between that numerator and denominator right there?
Well, it's a 3. And so it's like a number divided by itself.
So 3 divided by 3 would be what?
1.
So that marks out.
Yeah, and we say they cancel out, but what are they really doing?
They turn into a 1.
Yeah, we're dividing them, right?
So I'm sometimes picky. Sometimes people circle it, but when you circle it reminds me of 0. But 3 divided by 3 is a 1, so I'll make it be a 1.
Mm-hmm.
That becomes a 1. That becomes a 1.
And so what you're doing, we say we're canceling out numerator to denominator, but again, we're not really canceling. That's just what we say. We're dividing. 3 divided by 3 is 1.
Now, I'm left with 3 times 3 on the numerator. How can I simplify that?
I had to get a drink real quick, Miss Powell. My mouth is already drying out. Well, again, you can write that as, since it's a number, you can multiply it, or you can write it in exponential form, which would be 3 squared.
Now, look at my original problem and pretend I could skip all of this. What would be the shortcut here if I did 3 to the 5th divided by 3 to the 3rd?
Well, I think that I've got 2 3s left upstairs and no 3s left downstairs. And so why couldn't I just go ahead and subtract those exponents, Miss Powell?
You could. Now, is subtraction commutative? Does it matter if you do 5 take away 3 or 3 take away 5?
Right. The commutative property, remember, told us that we could multiply and add in any order. But with division and subtraction, commutative properties, it's out the door. You can't do anything commutative because subtraction and division order matters, okay? So it has to be the numerator's 5 minus the denominator's 3. It can't be 3 minus 5.
So it can't be that. So it has to be the top exponent minus the bottom exponent.
Right. And that's your shortcut. Again, only works with common bases, and it keeps you from having to write all of those bases out however many times. Miss Powell had a number up there a while ago. It was like 18 and 10, and I was like, oh my gosh, I don't want to write out that 3 18 times. I don't want to write out that 3 10 times. So shortcuts are good, right?
So let's do a shortcut. I don't want to have to write that out.
Yeah,
7 to
for
the
sure.
30th divided by 7 to the 21st power.
Right.
So what's going to be my answer?
Well, the first thing I see is they have common bases, right?
Mm-hmm.
So the shortcut doesn't work if you do not have common bases. So I'm going to write down the base, the 7, and then I'm going to take the numerator's exponent, subtract the denominator's exponent. Because like Ms. Powell said, it's not commutative. It's got to be, the order has to be numerators divided by denominators, okay? Or subtracted.
So it's the top exponent 30.
Right.
Minus the 21.
Yes.
And that gives me what?
I think that gives me 9, doesn't it, Ms. Powell?
Mm-hmm.
Yeah.
So it'll be 7 to the 9th.
Yeah, what a great shortcut, right, guys? And so I love that. We don't have to write out 37s and 21/7s and mark 7 out, 7 out, 7 out, 7 out. We just do the subtraction for the shortcut.
Now, this one would be pretty easy actually to write out the long way like we did a minute ago. We could write 4 times 4 times 4. The bottom would be 4 times 4 times 4. But when we went to simplify and do 4 divided by 4, you get a 1, a 1, and a 1. So I end up having no 4s left.
Well, you actually know if you go back to 4 divided by, or 4/3 divided by 4/3, we learned back probably in 4th or 5th grade, any number divided by itself is just what? 1. So this is any number 4 cubed divided by 4 cubed is still the same number, right? So I know it's going to be 1. But what if we did our subtraction rule with this one right here?
Okay, so the base is 4,
right.
So I still would put a base.
Yeah.
And I take the top exponent minus the bottom. So
okay.
3 take away 3 is?
Well, that gives me 0, does it?
Now, what did we find that anything raised to the 0 is?
Oh, yeah. Remember we said any number to the 0 power is equal to just 1. So look how this proves that out. Now with our subtraction rule, our little shortcut here, we know that any number divided by itself is 1. That's why that works, okay? So any number to the 0 power is automatically going to give you 1.
Okay, so what if we change it and we don't know what the numbers are, so we put a variable in place of an unknown number, and it's x to the 9th divided by x squared.
Okay, so wait a minute, Ms. Powell. So we had numbers as bases before. Now you're throwing in variables as bases?
Yes.
Is that going to change anything?
Shouldn't, as long as the bases are like each other and it's the same.
I think you're right. I think as long as we go x's with x's and y's with y's, then you're going to be good. So the rule is the same, right? You take the numerator's exponent, the top one, and subtract the denominator's exponent, the bottom one, and put it with a common base.
So if I do 9 take away 2, I get 7. So that's going to be my new exponent. My base stayed the same, x. My exponent becomes a 7.
Wow, that's a great shortcut, Ms. Powell.
Now, let's do the shortcut on this one. Now,
ooh, wait a minute now. That looks a little different.
Wow.
What is different about this one than the ones that we've been doing?
Well, I can still take the top exponent.
Right.
Subtract the bottom exponent because I have like bases.
Okay, but something doesn't look right here, Ms. Powell.
Well.
Oh, there it is right there.
So when I take 3 take away 5, I end up with a negative exponent. And yes, you can have exponents come out negative when you're trying to take more away from what you have. So if I wrote that out, I would keep the base 8 and I'd put a negative 2. Now, I think we might need to go back and look at what does that 8 to the negative 2 really mean?
Well, how about let's do this, Ms. Powell, and I think this is what you're going to do. Yeah, let's write it out the long way with 3 8s at the top and 5 8s at the bottom.
Now, what would happen there?
Well, we say we cancel, right? We're really dividing, but 1/8 in the top divides with 1/8 in the bottom. And so what that does is that leaves a 1 upstairs
Mhm.
and 8 squared downstairs, right?
Now, if we applied that rule a minute ago, I didn't get a +2. I got a
Right.
-2, but I
Right.
had written the 8 here with the -2. Does that mean that's equivalent?
I think that's what that means. So what you're telling me then, Miss Powell, is I can take a negative exponent and I can make it positive by just putting it in a fraction where it's in the denominator.
Right.
Okay.
Now, that's if it started off in the top numerator. So I kind of think of this as where you live in an apartment building. There's some
Okay.
people that move in, they want to be on the bottom floor because they're scared of heights.
All right.
But then you've got some people that don't like living on the bottom floor because they hear the people up above walking around.
Right.
So it just depends on where you want to live.
Mhm.
So I kind of think of this little 8 as being a person.
Only Miss Powell would think of the 8 as being a person.
This is how they're feeling. Now, I put a smiley face, but actually
If they're negative, they're kind of
negative. So really,
kind of a frowny face.
really don't like where he lives.
Right.
So, but if I move 8 where he wants to live in the downstairs apartment, now he's going to be happy
He becomes positive.
and it becomes positive.
Right.
So it just depends on the problem. So you might have different people. Now, see how the base did not change? The base will not change. That's a person. Only his feelings change, and his feelings are your exponents. So you've got to look at, you've got 4 different people here. Okay? So
Whoa.
let's say it says simplify to have all positive exponents. So you want everybody in this apartment building to be happy. X is a person. He has a positive exponent. Does he like where he lives?
Yes. He's
So-
positive, so he's going to stay.
So he's going to stay on top.
Right.
Now I have a person called Y that's raised to the -9 exponent. Does he like where he lives?
They don't like where they live, and the only way to make them happy is to move them downstairs.
Okay, so this is going to become Y to the 9th. Now, Z already lives downstairs, and he's raised to the -4 exponent.
Z's looking pretty negative. We got to make them positive.
So what would make him be happy if he lived downstairs?
Well, the only way to make them happy, positive, is to move them upstairs.
So as soon as he moves, the base stays the same. It's the same person, but now he's happy where he lives.
Right.
Now, what about the B?
Well, the B looks happy. It's positive, right? So it's okay to stay where it is. What Miss Powell's trying to get us to see here is that we can't leave negative exponents in any problem, okay? When we rewrite it or simplify, is what it might say. I think that's what your directions say there.
Mhm.
Simplify. Simplify means to get rid of all negative exponents. And so to get rid of negative exponents, you move them. If they're upstairs and they're negative, you move them downstairs to where they're positive. If they're downstairs and they're negative, you move them upstairs to where they're positive. And so, like Ms. Powell is saying, to make them positive, you got to move them opposite of where they are. Okay?
And if they're happy where they're at, if they were already downstairs and they're happy, they live
That's right.
downstairs.
If they're already positive, there's no reason to move them. They're already simplified as much as they can.
So that concludes the lesson over dividing like bases. So as a recap, if you divide like bases, you subtract top minus bottom.
Right?
Sometimes you get negative exponents.
Right?
And if that's the case, you have to change them around.
You want to make them positive, and the way to make them positive is to take them downstairs if they're upstairs or upstairs if they're downstairs.
Yep.
We move them to make them positive. We like happy renters, don't we, Miss Powell?
Yes, we like happy renters who pay the rent.
Okay, hey, we like happy students too. So you guys have a great day, and we will see you next time.